All right, we are going to do a quick demonstration of a dihybrid cross. This is going to be a little bit more advanced than our monohybrid crosses, but it functions basically in the same manner. So what we're going to be doing is, similarly, we're going to be segregating our parents' alleles. In this case, we're also going to be using the law of independent assortment to get different combinations of alleles. And then we're also going to be using the square to predict different genotypes and phenotypes that might arise. Dihybrid is called this. It's a dihybrid cross because now we're looking, instead of at one trait, we're looking at two traits. And so I have them identified down here. We have Q, which is going to give us a wide face for an alien, let's say. And a lowercase q will just give us a narrow face. And then capital Z is going to give us three eyes, while a lowercase z is going to give one eye to our alien. This is going to be, both of these are going to be complete dominance in terms of how, of their dominance patterns. And so I just want to keep this simple and focus really on how to do a dihybrid cross in a Punnett square. The first thing that we need to do, remember, in our monohybrid crosses is we need to segregate the alleles. And so what we would do in our monohybrid cross is we would take, for example, if we were just doing the Q's, we would take dad's Q's and we'd do capital Q, lowercase q. Mom's Q's, lowercase, lowercase. But in this case, since we have two different alleles here, the Q and the Z that we're going to be looking at, what we have to do is actually come up with the different ways in which these two alleles could combine. In other words, we could have capital Q, and this capital Q could get combined with our capital Z. Okay, so that's one possible allele outcome that dad could pass on to his offspring. He could also give us capital Q, lowercase q, or lowercase z rather. All right. He could also give us a lowercase q and a capital Z, which we'll write right here. And lastly, a lowercase q and a lowercase z. So dad could give us each one of these different possible allele outcomes. Oops, this should be lowercase. He could give us two capitals, both of the dominant alleles, and then two different heterozygous combinations, and then the two recessive alleles. Okay? We could get any one of these combinations from dad, depending on how his particular, what his gamete was. Now for mom, we're going to go ahead and do the same thing. Now what we notice with mom is that both of mom's Q alleles are lowercase, or the recessive alleles. So we can go ahead and fill in all lowercase q's across the board. That's the only thing mom can give us. Lowercase q, lowercase q, lowercase q, lowercase q. All right? But then we could get two different combinations. So we could get a lowercase q with a capital Z. Fill that in here. We could get this lowercase q with a capital Z. So there's two options there, two ways of getting that. And we could get a lowercase q with a capital Z, or a lowercase z, and this lowercase q with this lowercase z. All right? So mom can really only pass down two different combinations, the lowercase q with a capital Z, or lowercase q with a lowercase z. And now what we need to do is we're going to go through and fill out all 16 of these squares, and we're going to see two genotypes for each of these traits. So we'll have capital Q, lowercase q. We'll have capital Q, lowercase q. We will have lowercase q, lowercase q. And here we'll have lowercase q, lowercase q. And I'm just going to continue doing this, capital, lowercase, 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 and so on. So heterozygous, heterozygous, homozygous recessive, homozygous recessive, and one more, heterozygous, heterozygous, homozygous recessive, homozygous recessive. Okay, so we've gone ahead, we've filled out all of the Q alleles for the narrow or wideness of the face. Now we're going to go through and look at the different possibilities for the Z allele. So here we're going to get homozygous dominant. Here we're going to get heterozygous. This will be homozygous dominant, and here again, heterozygous. And I'm going to go through and do this for every single box. It's really important when you have two letters, uppercase and lowercase, that look similar, that you have some way of determining this capital Z. I make sure it looks different than my lowercase by putting the slash through it. Makes it easy then when I go back and try to analyze these that I don't make any mistakes. So I'm going to try to make sure I put my slash through my capital Z's. This one is homozygous recessive, heterozygous, homozygous recessive, heterozygous, homozygous recessive, heterozygous, and homozygous recessive. Okay, so we have 16 different possibilities. We got them all filled out. Now what we can do is we can calculate, or we can go through and we can fill in our phenotypes. So let's look at this. Let's do, we'll do green faces. How about? So we said if it has a capital Q, it's going to be dominant. So this is going to be a wide-faced alien. And it's going to have, it's got capital Z, so it's going to have 3 eyes. 1, 2, 3. Okay, there's our alien. Again, we're going to get that same exact phenotype here because we have both of the dominant alleles. 3-eyed alien. Okay, now we have lowercase q, homozygous recessive. That's going to give us the narrow face. But we're still going to get 3 eyeballs. Okay, and here again, narrow face, 3 eyeballs though, because we got this capital Z. All right, this is really pushing my drawing skills to the limit. Okay, wide face, 3 eyes. Wide face, 3 eyes. Narrow face, 3 eyes. Narrow face, 3 eyes. Wide, 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 narrow, 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 narrow. Okay, now I'm going to go back, fill in all my eyeballs. 3 eyes. Ooh, 1 eye. 3 eyes. 1 eye. 3 eyes. 1 eye. 3 eyes. 3 eyes. Okay, so there we go. We filled out the whole chart, and now we can go in and we can calculate different probabilities. So I'm just going to, let's see if I can try to delete all this stuff real quick. I'm going to get rid of this. Nope. That didn't work. Okay, I guess I'm not going to do that. But we can say, okay, what are the probabilities? What are the different options? What are the different outcomes that we could have? We could have, here, let's just erase it. Okay, so here I've redrawn this. We have all these 4 different phenotype combinations. Wide with 3 eyes, wide with 1 eye, narrow with 3 eyes, narrow with 1 eye. So let's go through and count these up. The wide with 3 eyes, we have 1, 2, 3, 4, 5, 6. Wide with 1 eye, we have 1, 2. Narrow with 3, we got 1, 2, 3, 4, 5, 6, 7. And narrow with 1 eye, we got 1. 2, 2, 2. Okay. So this should add up to 16. So 1 plus 7 is 8, plus 10 is 16. So those are our different combinations, and then if we wanted to find the likelihood of that happening, we could just go ahead and divide each of these by 16, and that would give us our percent likelihood of getting each of these different combinations. Okay, so that's just an example of how to do a dihybrid cross. Remember that you need to take your parents' different alleles and come up with the different combinations that they might pass on. And then you go through and you match them all up, and then you can draw on the different phenotypes. So it's a bit more elaborate, and we're only looking at two different genes. So just imagine all the different combinations that come about when we are looking at 20,000 genes that are in humans. And then each of our genes might have more than two variations. So there's just a lot of interesting things we can do with this. I hope you enjoyed it and don't make fun of my art. All right, I'll see you all guys later.